Hello. This is a video where I try to fix the frequency counter. Um, so the first part is me trying to characterize how it works, not very well, and then I go and fix the transistor or the JFET and test it again. So the problem is, so it's working now. So we're measuring 9.7598 and the oscilloscope's outputting 9.976. But the amplitude is 100 millivolts. And I saw a video with the designer made his own frequency counter using the same front end, and he can go down to 10 millivolts. And if I do that, if I go to 10 millivolts, we get 0. So if I keep on raising it now, and okay, so that's 19 millivolts. That's counting 508. It's just on the verge. So if I go to 23, but I want 9.97. So if I go to, that's not bad. So it's 30 millivolts. So 9.9759. That's probably correct. So about 30 millivolts when it should be down to probably 10. But the problem is if I change to a sine wave, it needs a lot more amplitude. That's sort of working. 36, 9.97. Let me just, so if I get to 10, if I turn it to 100 millivolts, so when do I lose it? Just lowering the amplitude now. Mm, 60 millivolts. So 40, 30. So now it's starting to, now it's failed, 20. But if I then, it's meant to work, I think, to at least it's 100 megahertz, and I'm only up to the maximum frequency is 20. So that's I've just set 20 megahertz, 27 millivolts. So that's when you get to the higher frequencies, it's really bad. So now if I raise that, I just raise it to 77 millivolts, and I'm getting 10.9.8. Should be 20 megahertz, but it's not. It's unstable. So, oops, 160 millivolts. So that's about, so I think it'll go down to about, so you need to get about 100, at 20 megahertz, it needs about 110, 100 millivolts. It's still unstable a little bit. That's not right. That's better. So now 130 millivolts, it's 19.49s, which I think is pretty accurate. Again, I can't tell. I'm sort of judging by how if the oscilloscope says 20 megahertz, then if I get 19.49s, I mean it's probably not a coincidence. And if I do that at different frequencies, and I believe that I checked the oscilloscope specs, and it's only, we're in the ballpark of what it's been calibrated to now. But yeah, I would like to have another instrument that I could actually check this. So what I'm going to do is, hopefully, I don't want to because it's cold out there, I'm going to go to the garage and take this apart and rotate It's a J, I think it's called a J310, the JFET, and hopefully that makes a difference. So the transistor is Q1, which is there. This is not going to be pleasant. I just noticed I hadn't screwed that in properly. Neither that. I don't know that. I'm just experimenting with. I'm surprised that the phone camera doesn't work with the lighting very well. Looks like I've got a few things to improve. It's about as cold as a fridge in here. Okay. It's gonna fit. No, it's not. Okay. Maybe I should have brought a screwdriver from inside. Okay. So I've got to rotate that around. So essentially swapping those two pins. If that's, I can't see if that's in view. Okay. And then probably have to readjust the pot. Yeah. But I'm going to, I should have used SMA connectors. This is ridiculous. It's difficult to, I use element 14, but it's difficult to find the thing that you need. So that's the GPS, and I need to get an another SMA connector here so that I can plug that in. So at the moment it's a bit silly. But these BNC coax is not real great, and it needs an internal power supply. So I want to respin this board too, so that it's got a linear regulator on it. So yeah, there's an Arduino. Is that in shot down here? Maybe Arduino Pro Mini, I think that is. I'd like actually to put that on there, but I'm not sure. I want to avoid getting interference, and just an LCD, the standard ones. Oh man, it's cold. No. problem is I've got to be able to actually see this. Tweezers, tweezers, tweezers. What temperature? 360. I don't know. I haven't got a. That doesn't look good. These are not good quality, I don't think. The tinning's not working. Oh, yes it is. That's alright. This is not going to be fun. The possibility of destroying this is high. Yes. How am I going to get... This is the part that I didn't... How? I need a heat gun. Oh, come on. How are we doing something? Well, something probably not good. How do I... This is a JFET. How sensitive is it? Oh, come on. I have another one somewhere, I think. I hope. Maybe I should put this one back on because I might be... I need another soldering iron. I don't have one. Are we too cold? It's so cold in here, I think the soldering iron doesn't work. It's a bit... Oh yes. Does that mean we're taking it off the something? Okay, one leg. Really hope I'm not destroying the board. Okay. I think what's happened is it's just on a blob of solder now. My beautiful board is being hacked. Although I have quite a number of others, but I do not want to. Oh, come on, man. Yeah, this is not fun. Do it before my fingers freeze, that's the main thing. That doesn't look good. That does not look good at all. That is a hack. Oi! That is a hack. Let's have a look. Oh, this probably won't film. I need millions of subscribers so I can buy a camera. This is... Did I actually push record? Yeah, I think so. What are we doing? How hot did we get this? I do not... Okay. I think it wants to go back on there. Which end? I just dropped it. Oh, I hate that. Surface mount. Don't breathe. I just dropped it. No, I can't see it. I'm gonna cut this bit out. Oh. How? How could I drop it? There it is. Oh my God.
I was stupid. Why didn't I put SMA? Don't drop. I bet you. No, I won't drop it again. I'm not going to drop it again. Okay. There we go. Somehow, this is ridiculously difficult. Wow, it's not too bad. Okay. Yep. We have hacked this thing. But I can barely see. Oh, that's awful. Hopefully the transistor's still the right way up. That would be just... That would... How am I going to get a connection? Oh my god. I'm in a little bit of a loss to do this. What am I going to do? I'm going to do that, maybe. No, it's not long enough. No, I should probably measure it, but that would be too much like work. There. So what I'm hoping now to do is... Oh, I can't stay any much longer, it's freezing. Okay. Okay. Yeah, so tin these. We'll solder them. Ah, come on. Ah, that's what I don't like. Ow. I'm soldering it to my finger. So now what I want to do is hack it even more and put a bridge from that pin like this. Oh, come on. It's not going to work. Need more solder. Oh, come on. Get off. A big chunk of solder on there. If this works, I'm gonna be surprised. Oh I thought it had gone into invisibility. Alright. Yikes. How the shit. No way to swear in YouTube videos. Oh my goodness. Probably this is not gonna. It's so blurred. There we go. I'll go back to running the other way, I think. Maybe not. There you go. That is not good because of certain, but it might work. Okay. Oh, okay. Yep. Next version 2 going to be addressing some of these issues that I'm seeing. For instance, that. I think that can't do that. Oh, come on. I think I'm doing this way. Oh, wait, I've got to screw down there. Yeah. Yeah. Okay. Oh, come on. Why? Yeah, SMA cactus. So they can have 4 screws at each. Oh, wait a minute. I think there's been 4 versions of the logic board. The first was point-to-point soldered. And then just smaller and smaller and smaller. It's because that's a 4-layer board, that one. Which I like. Even if you don't really need it, it's good because you just have power and ground everywhere. Just have to put a VIA up through them. Get it. It's excellent. It's one of my favourite things. And the first version was really noisy. It's power supply. Oh no, just the signals all interfere with each other. This one, I think I measured. That's the wrong size screwdriver. Okay, now I haven't pulled anything. Forget what that is. Oh, there was an extra chip. I took it off. Good? I think. Let's check it again. Paranoid. Yeah. Okay. Oh, everything is freezing. Oh, man.
So I'm back, and I think it might be improved. And now I'm using the camera. I was using the phone camera in Pro Video mode, but I think I must have stuffed up the settings because now it looks heaps better, which is annoying. Oh, it's still not great. Why does it do that? So 20 megahertz sine wave, 30 millivolts, and I'm reading 19.4935, and it's pretty stable. So maybe I've improved it. I'm going to replace the JFET with a new one, I think, though, because it may have got damaged. So now I probably can see the internals properly. So you can see the lights. So I like to have LEDs. So there's a power. There's a power LED. I'm going to turn the. Oh, it's not much good. So there's a power LED to the top left, but then another LED, which means that the Arduino has set up this, which is a I2C to parallel to I/O port, because I needed more wires to control the frequency counter board. And this is the GPS, which is programmed with a serial port. I think that's why I ran out of pins on the Arduino. So you need to there's a programmable divider on the GPS chip, that's how I get the 3 time bases, and that's why this chip is no longer necessary. That's just a division stage, which I didn't need because I figured out how to control the divider on here. So I used my logic analyzer to get the serial. So you use there's an application you can use to control the GPS, and I just intercepted the serial. And this is the if we can't see it. Oh yeah, this phone's just not good enough to do this. There's that wire bridge over so I've rotated that right in the middle, sort of, that surface mount transistor, rotated it and then bridged over to the base. I'm not happy with it though. I still don't think it's working as it should. It's 20 megahertz, but maybe 20 megahertz is on the low end, and that's the problem, because I think the design of this board, I think it's meant to go to about 150 megahertz, but I don't have a generator that goes that high. I need to find out if I can borrow one or something. Yeah. So that's just the range switch. There's the Arduino, which I really want to make my own board for Pro Mini with mounting holes, because for some reason the cheap eBay ones don't have any mounting holes. So I've had to do this horrible thing. Yeah, that's the 4-layer board. It's got these boards with the ground planes, especially the 4-layer one. There's the noise. I got rid of all the noise that was occurring on there from the switching. Anyway, I hope someone finds this interesting, but it's not fixed, I don't think. I'm not happy with it. I mean, 30 millivolts is better than 110. And I don't know. I sort of expected a frequency counter to be much more stable than this. I've never used one. I don't think. The only one that I've used is the one that's built into this the oscilloscope. So it won't do anything, but why is that doing that? Oh, because it's just floating. It's measuring the 50 hertz line frequency. So, but this is, yeah. If I use this channel onto here to measure as well, it means that the signal's weakened, so it stuffs everything up. Anyway, thanks for watching.